Yes. Good evening, students. Yes. So today we'll start with the third chapter, matrices. So let us start the session. In this chapter, we are going to discuss the definition of matrix, different types of matrices, operations on matrices, transpose of a matrix, then symmetric and skew symmetric matrices, as well as invertible matrix. Now let us discuss one by one. What is the meaning of the matrix? Yes. A matrix is a rectangular arrangement of numbers or functions enclosed within square bracket. Say A, B, C, D, E, F. Horizontal row of representation is called row of a matrix, whereas the vertical way of representation is known as column of matrix. So in this particular example, what I took, we usually denote a matrix by capital letter. I took A equal to square bracket and I had listed few elements A, B, C, D, E, F. Here, A, B, C forms first row of the matrix. D, E, F forms second row of matrix. So in this particular case, I have two rows, whereas A, D forms first column, B and E forms second column, C and E forms third column of the matrix. So a matrix is a rectangular arrangement of numbers or functions. Need not be ABCD, can be any real number or even trigonometric functions or any functions as I wish. And we usually denote square bracket for the representation. E1 round bracket is also allowed. Yes. Next, when I consider this example, here there are two rows and three columns. A is first row, first column entry. B, first row, second column entry. C, first row, third column entry. Whereas D, second row, first column entry. E, second row, second column entry. F, second row, third column entry. Now, in general, if I want to write a matrix, general matrix A denoted by Aij is given by A11, first row, first column entry. A12, first row, second column entry. A13, first row, third column entry. And so on. Suppose if I'm going to consider n rows, nth row entry will be, first row, nth column entry will be A1n. Next, second row, first column, A21. Second row, second column, A22. Second row, third column, A23. And so on. Second row, nth column, A2n. And so on. If I want to identify the mth row entry, AM1. First suffix indicates mth row, whereas the second indicates first column. AM2. M indicates mth row, 2 indicates second column. AM3, etc. AMN. Now, if I consider a particular row, say second row, entries are A21, A22, A23, etc. A2n. Throughout, the row value remains the same. That is 2, 2, 2. The first suffix will remain the same. Yes. Now, if I consider this particular one, ith row, consider ith row, jth column entry, or else ijth entry. If I consider it is just aij. Why? Look at here. A23 is nothing but second row, third column entry. So, ith row, jth column entry will be aij. If I consider this mth row, second column entry, AM2. Hope the concept is clear to all. Yes? Any doubt? Yes. Next, few examples for matrix. Let me write. Example, A equal to matrix 1, 2, 3, 4, 5, 6. B is equal to matrix 2, 3, 4, 0, 5, root 2, minus 1, 7, 3 by 2. One particular matrix, say matrix B. Now, consider the first matrix. In the first matrix, there are 2 rows and 3 columns. Whereas in the second matrix, there are 3 rows and 3 columns. Yes. Now, in general, if I consider a matrix with m rows and n columns, we can say that order. I'll use one word, order. Order of the matrix as m by n. We use the multiplication symbol and we read this as m by n. M by n indicates in the particular matrix, there are m rows and n columns. Thus, if I consider A, order of matrix A, we usually denote this to write the order. Order of the matrix A is nothing but 2 by 3. 2 rows, 3 columns. So, order of A is 2 by 3. Consider B. Order of B. There are 3 rows, 3 columns. So, I can write 3 by 3. One more if I consider. C is equal to, say, sin x, cos x. Order of C. There are 2 rows, single column, 2 by 1. Yes. In this case, if I consider first row, first column entry is sin x. First column entry is cos x. Order of the matrix is 2 by 1. Now consider the first example again. In the first example, order of the matrix 2 by 3. How many entries are there? See the entry. 1, 2, 3, 4, 5, 6. There are 6 entries. Order of the matrix 2 by 3. Number of entries 6. What about in the second? There are 3 rows, 3 columns. So order of the matrix 3 by 3. Consider the number of entries. There are altogether 9 entries. Consider the third example. Order of the matrix 2 by 1. Number of entries 2. In general, very important, whenever I consider order of the matrix, if order of the matrix is equal to m by n, then number of entries, or I can use the word elements. Number of elements in A is equal to m into n. So first example, order 2 by 3, number of entries 2 into 3, 6. Order of B equal to 3 by 3, number of entries 3 into 3, 9. Order of C equal to 2 by 1, number of entries 2 into 1, 2. Hope the concept is clear. So, I'll just recall whatever we had gone through right now. We came across definition of matrix. A matrix is a rectangular arrangement of numbers or functions written inside either square bracket or round bracket. And we denote matrix by capital letter. Say A or matrix B is equal to. Yes. And the entries inside, say A, B, these are elements or entries of the matrix. I'll consider one example here, A, B, C, D. So A and B forms first row of matrix. The horizontal representation forms row of matrix. The vertical representation forms column of the matrix. So in the particular example, A and B entries of the first row, C and D entries of the second row. Whereas A and C forms entries of the first column, B and D forms entries of second column. If I consider the entry, say B is first row, second column entry. I can denote it by A12, first row, second column entry. Whereas if I consider D, it is the second row, second column entry. I can use A22, second row, second column entry. First suffix indicates the row in which the entry lie, whereas the second indicates the column in which the entry lie. So, then we came across order of the matrix. Order of a matrix is the number of row by number of column. If I consider a matrix with m row, n column, we say that order of the matrix m by n. If I consider this particular example, 2 rows, 3 columns, so order of the matrix is 2 by 3. Yes. Whenever a matrix having m row and n column, or else order of the matrix m by n, then the number of element is m into n. Yes. Now let us do is we'll go through simple problems on the particular concept. ಎಲ್ರಿಗೂ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. Yes. Let us do some problems. Yes. Yes. First problem. Write down. In the matrix, A is equal to 2, 5, 19, minus 7. 35, minus 2, 5 by 2, 12. Root 3, 1, minus 5, 17. Consider this particular matrix. Now the question is to find. First question, order of the matrix. Second question, number of elements. Third question. Write the element A13, A21, A33, A24, A23. Yes. Yes, Suresh. Okay. My concept explain ಮಾಡ್ತೇನೆ. Just listen. Matrix is rectangular arrangement of numbers or functions. Yes, exactly. Few of them already started answering. Very good. Very good. Rectangular arrangement of numbers or functions. ಈಗ ಈ particular matrix ಅಲ್ಲಿ the horizontal way of representation known as row of matrix, whereas the vertical way of representation is known as column of the matrix. So, if I consider this particular example, there are 3 rows as well as 4 columns. Order of the matrix, number of rows by number of columns. There are 3 rows, 4 columns, and hence the order of the matrix is 3 by 4. Exactly. Many of them gave the answer, right answer. Number of element. When a matrix is of order m by n, number of elements m into n. 3 into 4, 12. Next question is to find A13. That is first row, third column. Exactly. Yes, Ramappa gave the answer. Many are answering. Very good. A13 indicates the first row, third column entry. In the first row, identify the third column entry. Yes, exactly. A13 is 19. First row, third column entry. What is A21? According to the definition, A21 is nothing but second row, first column entry. Second row, first column in the particular example is 35. Yes, yes. Next, A33. Third row, see here, first indicates the number of the row in which the particular entry lies, and the second suffix indicates the column in which the particular entry lies. So if I consider A33, it is nothing but third row, third column entry, which is -5. If I consider A24, A24 is nothing but second row, first column entry. Second row, first column, sorry, A24. Second row, fourth column entry, 12. Yes. Now, hope the concept is clear. Go through A23. Second row, third column. A23 indicates second row, third column entry, which is 5 by 2. Which is 5 by 2. So, when a matrix is given, identify the number of rows, number of columns. Order of the matrix is given by number of rows into number of columns. Always row comes first, column next. When order of the matrix is m by n, number of entries m into n. ಮತ್ತೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ A13 ಕೇಳಿದ್ದು. A13 by definition, first row, third column entry. Go through first row, identify the third column, mention the entry. In the particular example, it is 19. Yes, many of them had given the right answer. Very good. Yes. Very good. Now let us move further. One more example. Yes. Consider one example. If a matrix has 24 elements, write down. If a matrix has 24 elements, What are the possible order it can have? What are the possible order it can have? Read the question carefully. We know already the meaning of the word order of the matrix. If a matrix has m row, n column, then order of the matrix is m by n. When a matrix is of order m by n, number of elements m into n. Just use this concept in order to answer. We are given with a matrix having 24 elements. Now the question is to identify what are the different possible orders it can have. How to identify? Yes, identify all possible factors of 24 because mn, number of entry, order m into n. Use this concept. Yes, exactly. So I'll write one by one. 24 can be rewritten as 1 by 24, 24 into 1. 2 into 12, 12 into 2. 3 into 8, 8 into 3. 4 into 6, 6 into 4. No other possibility. How many are there? Yes, there are 8 different ways. Very good. Many of them had given the right answer. Whenever a matrix has 24 elements, possible orders are 1 by 24, 24 by 1, 2 by 12, 12 by 2, 3 by 8, 8 by 3, 4 by 6, 6 by 4, altogether 8. Nagaratna, there are 8 different possibilities. Yes, yes. Answer is 8. Yes. Now I'll change the question. What if I consider 13 elements? Answer me now. If a matrix consisting of 13 elements, what are the different possible orders it can have? Answer to this question now. Number of elements 13. What are the different orders it can have? Yes. Many are answering. Yes, very good. 13 is a prime number. So its factors are just 1 and 13. Hence the possible order 1 by 13, 13 by 1, nothing else. Exactly. Only 2. Only 2. One more you just identify. What if I consisting of 18 entries? Next question up to you. Answer to this. Yes, very good, very good. Many are answering. What if I consider order 18? Identify right now. Identify all possible factors of 18. Which are they? 1 by 18, 18 by 1. 2 by 9, 9 by 2. 3 by 6, 6 by 3. No other possibility. Hence, there are 6 possibilities. Hope the question is clear. Write all different possible orders of or factors of 18. 4 ಸುಮಾರು ಜನ 4 ಅಂತ ಆನ್ಸರ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಚೆಕ್ ಮಾಡಿ. ಐಡೆಂಟಿಫೈ ಆಲ್ ಡಿಫರೆಂಟ್ ಪಾಸಿಬಲ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆಫ್ 18. Yes, yes. Okay, yes. Very good. 6 possibility. ಒಂದು 1 by 18. See, identify all possible factors of 18. 1, 18. 2, 9. 3, 6. Identify different possible orders. ಕಾನ್ಸೆಪ್ಟ್ ಎಲ್ರಿಗೂ ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೇನೆ. ಲೆಟ್ ಅಸ್ ಮೂವ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. Yes. 2 and 9 also is there. Yeah, 2 and 9. Two 9 unto 9 unto 118, 18 1, 3 6, 6 3. These are the 6 different possibility. Altogether, 6 different ways for matrix with 18 entries. ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಯ್ತಲ್ಲ? ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲದಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ಗೆ ಹೋಗ್ತೇನೆ. ಬೇಕಿದ್ರೆ ಇನ್ನೂ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ. ವಾಟ್ ಇಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ 12 elements? ಇದಕ್ಕೆ ಆನ್ಸರ್ ಮಾಡಿ ನೋಡ. ಇಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್, ಈಗ ಪ್ರೀವಿಯಸ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ದು ನಾನು, ಈಗ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ವಿತ್ 18 ಎಲಿಮೆಂಟ್ಸ್, ಕ್ವಶನ್ ಕೇಳಿದ್ದು ಐಡೆಂಟಿಫೈ ಆಲ್, ಎಸ್, ಐಡೆಂಟಿಫೈ ಆಲ್ ಡಿಫರೆಂಟ್ ಪಾಸಿಬಲ್ ಆರ್ಡರ್ಸ್. 18, identify all the factors, can be rewritten as 1 into 9, sorry, 1 into 18, 1 into 18, 18 into 1, 2 into 9, 9 into 2, 3 into 6, 6 into 3. ಬೇರೆ ಯಾವುದು ಕೂಡ 18 ನ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅಲ್ಲ. So there are only 6 possibilities. ಅದೇ ಈಗ ನಾನು 15 ತಕೊಂಡ್ರೆ 1 by 15, identify all possible orders. 15 by 1, 3 by 5, 5 by 3. ಬೇರೆ ಯಾವ ಫ್ಯಾಕ್ಟರ್ಸ್ ಕೂಡ ಇಲ್ಲ. So all together only 4 different possibilities. ಈಗ ಗೊತ್ತಾಯ್ತಲ್ಲ? ಮತ್ತೊಂದು ಎಕ್ಸಾಂಪಲ್ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದು 12. ಇದರದ್ದು ಆನ್ಸರ್ ಮಾಡಿ. ಈಗ ನಾನು 12 ತಕೊಂಡ್ರೆ ಎಲ್ಲ 12 ಇದು ಎಲ್ಲಾ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿ ನೆಕ್ಸ್ಟ್ ಆನ್ಸರ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಒಂದು 1 by 12, 12 by 1, 2 by 6, 6 by 2, 3 by 4, 4 by 3. ಬೇರೆ ಯಾವ್ದಾದ್ರು ಉಂಟಾ? ಬೇರೆ ಯಾವುದು ಕೂಡ 12 ನ ಫ್ಯಾಕ್ಟರ್ಸ್ ಅಲ್ಲ. I have only 1, 2, 3, 4, 6 and 12 as factors. Hope the concept is clear. Thus, all possible different orders are 1 by 12, 12 by 1, 3 by 4, 4 by 3, 2 by 6, 6 by 2. Altogether 6. Yes, very good. ಇನ್ನೊಂದು ಕ್ವಶನ್ಗೆ ಹೋಗುವ. ಬೇರೆ ಟೈಪ್ ಇದೆ ಕ್ವಶನ್. ಎಸ್, ನೋಡ, ಟ್ರೈ ಮಾಡಿ. construct a 2 by 2 matrix A equal to Aij, whose elements are given by Aij is equal to I plus j whole square divided by 2. ಕ್ವಶನ್ ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಂಡೆ. Construct a 2 by 2 matrix A equal to Aij, whose elements are given by Aij equal to I plus j the whole square divided by 2. How to do the problem? 2 by 2 matrix, order of the matrix 2 by 2, it will have 4 entries. In such a way that there are always 2 rows and 2 columns. Two rows, 2 columns. So first ನೀವು general matrix ಬರ್ಕೊಳ್ಳಿ. 2 rows, 2 columns in a general matrix and ಬರ್ಕೊಳ್ಳಿ. So I'll write A equal to 2 by 2. So there are 2 rows, 2 columns. First row A11, A12. Yes. A13 ಬರೆಯುವ ಅಗತ್ಯ ಇಲ್ಲ, ಬರೀಲಿಕ್ಕಿಲ್ಲ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ there are only 2 columns. A13 ನಾನು ಬರ್ದ್ರೆ there will exist 3 columns. So I'll move to the next. A21, second row, first column. A22, second row, second column. ಇದು general matrix of order 2 by 2. A12, A11, A12, A21, A22. General matrix of order 2 by 2. Now you need to list the elements. ಎಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? ijth entry is given by I plus j the whole square divided by 2. So identify one by one. First problem, let me write all the steps in detail. A11, aij I plus j the whole square by 2. So A11, 1 plus 1 the whole square divided by 2. Question ಅರ್ಥ ಆಯ್ತಲ್ಲ? 1 plus 1, 2, 2 square 4, 4 by 2 equal to 2. A12, by definition aij is I plus j the whole square. So A12, 1 plus 2 the whole square divided by 2. 1 plus 2, 3, 3 square 9, 9 by 2. Decimal form ಅಗತ್ಯ ಇಲ್ಲ. 9 by 2, keep it as it is. Next, A21, by definition 2 plus 1 the whole square divided by 2. Add ಮಾಡಿ. 2 plus 1, 3, 3 square 9, 9 by 2. Yes, very good. Many are answering right now. A22, definition apply ಮಾಡಿ. aij I plus j the whole square by 2. A22, 2 plus 2 the whole square divided by 2. 2 plus 2, 4, 4 square 16, 16 by 2 is 8. I found all the entry. Question is to construct the matrix. That's why you need to write in the form of matrix. Answer A11, 2, A12, 9 by 2, A21, again 9 by 2, A22, 8. That's the answer. ನೋಡಿ ಮಕ್ಕಳೇ, ಕ್ವಶನ್ ಕೇಳಿದ್ದು ಕನ್ಸ್ಟ್ರಕ್ಟ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಜಸ್ಟ್ A11, A12 ವ್ಯಾಲ್ಯೂ ಐಡೆಂಟಿಫೈ ಮಾಡಿದ್ರೆ ಸಾಕಾಗೋದಿಲ್ಲ. ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಎಸ್, ಅರ್ಥ ಆಯ್ತಲ್ಲ? ಎಸ್, ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ, then write in the form of matrix. ಕ್ವಶನ್ ಕೇಳಿದ್ದು 2 by 2 matrix. 2 by 2 matrix ಅಂತ ಹೇಳಿದ್ರೆ there are 2 rows and 2 columns. ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿ. ಎಸ್, ಇನ್ನೊಂದು ಕ್ವಶನ್ ಮಾಡುವ. Construct a 2 by 2 matrix. Construct a 2 by 2 matrix. A equal to aij such that aij is equal to I by j. ನೋಡ ಮಕ್ಕಳೇ, ನೀವೇ ಸಾಲ್ವ್ ಮಾಡಿ, ಟ್ರೈ ಮಾಡಿ. ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ ನೋಡ. ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಎ 2 by 2 ಮ್ಯಾಟ್ರಿಕ್ಸ್. A equal to I by j. A equal to ij given by I by j. ಟ್ರೈ ಮಾಡಿ. Yes. General matrix ಅಗತ್ಯ ಇದ್ರೆ A11, A12, A21, A22. Yes, ಶೋಭಾ. ಇನ್ನು ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡ್ಕೊಂಡು ಬನ್ನಿ. A11 by definition, if needed, let me write A11 I by J. I and J are 1 each. A12 1 by 2. A21 2 by 1 2. A22 2 by 2. Very good, very good. Many of them had given the right answer. ಈಗ ನಾನು ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಆಯ್ತು. Now write in the form of a matrix. 1 1 by 2 2 1. Very good, very good. So first ಕೊಟ್ಟ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನ ಆರ್ಡರ್ ಐಡೆಂಟಿಫೈ ಮಾಡಿ write the general entries of the matrix. ಜನರಲ್ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಆದ ಮೇಲೆ ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಕೊಂಡು ಬನ್ನಿ. ದೆನ್ ರೈಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಎಸ್, ವೆರಿ ಗುಡ್, ವೆರಿ ಗುಡ್. ಇನ್ನೊಂದು ಕ್ವಶನ್ ಟ್ರೈ ಮಾಡಿ ನೋಡ. ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಅ 3x4 matrix whose entries are given by Aij is equal to half mod minus 3i plus j. Modulus, hope you know the definition. Mod x is x if x greater than or equal to 0 minus x if x less than 0. ಇಲ್ಲಿ ಡೆಫಿನಿಷನ್ ಅಗತ್ಯ ಇಲ್ಲ. Modulus of minus 5 is plus 5. Modulus is used to ignore the negative sign or to take the absolute value of the real number or the function, whatever it be. So, ಈಗ ನಾನು modulus of 3 ತಕೊಂಡ್ರೆ 3. Modulus of minus 2 ತಕೊಂಡ್ರೆ answer will be 2. Use that concept and identify the values. Try ಮಾಡಿ ನೋಡ. Order 3 by 4. So first identify general matrix of order 3 by 4. 3 by 4 ಅಂತ ಹೇಳಿದಾಗ 3 rows 4 columns. General matrix ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ. A11, A12, A13, 4 columns. So up to A14. Next second row ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ. A21, A22, A23, A24. Third column list ಮಾಡಿ. A31, A32, A33, A34. Fourth column A34. Fourth row ಅಗತ್ಯವೇ ಇಲ್ಲ. Why? Because it is a matrix of order 3 by 4. Only 3 rows and 4 columns. Now, identify the elements one by one. So let me consider one by one. A11. Yes. Very good. Dakshani. Yes. 1th entry. 1 by 2 into minus 3 into 1. If needed, let me write minus 3 into 1 plus 1. Simplify, madam. 3 into 1, 3. Minus 3 plus 1, minus 2. Modulus of minus 2, 2. Extra half. Half into 2 equal to 1. Yes, very good, very good. Yes, Kumar. Yeshu. Yes, Dakshani. Very good. ಒಂದೊಂದೇ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಿ. A12 by definition 1 by 2 mod minus 3 into 1 plus 2. Minus 3 into 1 minus 3. Minus 3 plus 2 is minus 1. Modulus of minus 1 is 1. 1 into half. Yes, very good. ಅದೇ ತರ ಉಳಿದ ಎಂಟ್ರೀಸ್ ಅನ್ನು ಮಾಡಿ. A13 1/2 mod -3 into 1 plus 3 -3 plus 3 0. 0/2 is 0 itself. A14 1/2 mod -3 into 1 plus 4 -3 plus 4 1 into half half. Next second row ಗೆ A21 1/2 mod -3 into 2 plus 1 which is equal to -3 into 2 -6 plus 1 -5 mod 5/2 ಆನ್ಸರ್ 5/2. ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಯ್ತಲ್ಲ? ಅದೇ ತರ ಉಳಿದ ಎಂಟ್ರೀಸ್ ಅನ್ನ ಐಡೆಂಟಿಫೈ ಮಾಡಿ. ಸೊ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ A22 1/2 mod -3 into 2 plus 2 -6 plus 2 -4 modulus of -4 plus 4 4/2 equal to 2. Next A23 1/2 mod -3 into 2 plus 3 -6 -3 into 2 is -6 -6 plus 3 is -3 modulus of value 3, so the value is 3/2. A24 1/2 mod -3 into 2 plus 4. Simplify ಮಾಡಿ. -6 plus 4 -2. Mod -2 is 2. 2 and half, the product is A31 1/2 mod -3 into 3 plus 1 -9 plus 1 -8 modulus value 8. 8/2 is 4. Yes, very good. A32 1/2 mod -3 into 2 plus 2 -6 plus 2 -4/2 is 2. A33 I'll write it here. A33 half mod -3 into 3 plus 3. What it will be? -9. -9 plus 3 is -6. Modulus value is 6. 6/2 is. ಗೊತ್ತಾಯ್ತಲ್ಲ? ನೆಕ್ಸ್ಟ್ ಇಂದು A34 1/2 mod -3 into 3 plus 4 -9 -9 plus 4 modulus value 5/2. Yes. ಇಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಡೌಟ್ ಉಂಟಾ? ಇನ್ನೆಲ್ಲ ಎಂಟ್ರೀಸ್ ಐಡೆಂಟಿಫೈ ಮಾಡಿದ ಮೇಲೆ ರೈಟ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಲಿಸ್ಟ್ ಇನ್ ದಿಸ್ ಫಾರ್ಮ್. Yes, A34 is 5/2. Yes. ಇಲ್ಲಿ ನಾನು A32 A33 ಎಸ್ ಕರೆಕ್ಟ್. ಇಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ದೆ. A32 ಈಸ್ -3 into 3 -9 -9 plus 2 -7 modulus value 7, so it is 7/2. 7/2. ಎಸ್, ನಾನು ಎಂಟ್ರಿ ಬರ್ತದ್ದು ರಾಂಗ್ ಆಗಿತ್ತು, ಜಸ್ಟ್ ಕರೆಕ್ಷನ್ ಮಾಡ್ಕೊಂಡೆ. ಎನಿ ಡೌಟ್? ಎಸ್, ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. So till now we discussed about different types of matrix. Sorry, what is the definition of matrix? Then order of matrix. We came across number of entries in a matrix. Then how to identify or how to construct a matrix when the general entries are given. Yes. Yes. ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಾಯ್ತಲ್ಲ? Now we will discuss different types of matrices. Yes. ಯಾವುದೆಲ್ಲ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಒಂದೊಂದೇ ಮೆನ್ಷನ್ ಮಾಡ್ಕೊಂಡು ಬರ್ತೇನೆ. ಫಸ್ಟ್ ಒನ್ ರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್, ಕಾಲಮ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಥರ್ಡ್ ಒನ್ ರೆಕ್ಟಾಂಗ್ಯುಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ನೆಕ್ಸ್ಟ್ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್, diagonal matrix, scalar matrix, identity matrix, null matrix. These are the different types of matrices. One by one, let me discuss the concept. First one, row matrix. Row matrix in the sense matrix consisting of single row, any number of columns. For example, matrix 1, 2, 3, 4. Matrix 0, 5, -1. These are the example for row matrix. Matrix consisting of single row. Number of columns can be anything. Say, for example, if I consider the first example, only one row, whereas 4 columns. When I consider the second example, only one row, there are 3 columns. These are the examples for row matrix. Next, column matrix. What's a column matrix? A matrix consisting of single column, any number of rows, is called column matrix. Example, A equal to A, B, C, 3 rows, single column, 3 by 1. Three, 1, 0, -2, 5 by 2. Another example. There are 5 rows, single column. Order of the matrix is 5 by 1. Matrix consisting of single column, hence known as column matrix. ಗೊತ್ತಾಯ್ತಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್? So, row matrix in the sense matrix consisting of single row. Column matrix in the sense matrix consisting of single column. In the case of column matrix, row number of rows can be anything. Any number of rows. Maybe, see, I had given example, 3 by 1, 3 rows, single column. 5 by 1, 5 rows, single column. But number of columns should be 1. Yes. Next, third one. Rectangular matrix. A matrix of order m by n, where number of rows not equal to number of columns, is called rectangular matrix. Matrix with M number of rows, N number of columns, where M and N are not equal, is called a rectangular matrix. Example, A, B, C, D, E, F. ಈ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ there are 2 rows, 3 columns. So it is a matrix of order 2 by 3. Number of rows should not be equal to number of columns. Matrix with unequal number of rows and column is an example for rectangular matrix. ಈಗ ಇಲ್ಲಿ ಮೇಲಿದನ್ನು ಕಂಪೇರ್ ಮಾಡಿ. Clearly, both row and column matrices are rectangular matrices. Yes. So, for example, row matrix 1 by n. Order of a row matrix 1 by n. The example for a column matrix, I can consider the example m by 1. Column should be 1. Number of columns m by 1. In the case of rectangular matrix, number of rows not equal to number of columns. Say I can consider m by n. Concept artha aitalla? Yes. Next we'll move to the next one. Null matrix. What do you mean by null matrix? Null matrix, also known as void matrix, is a matrix in which each and every entries are 0. All the entries of a null matrix are always 0. 0, 0, 0. 0, 0, 0 is an example for a null matrix. We usually denote a null matrix by capital O. O equal to order of the matrix in the particular case. 2 rows, 3 columns. There are 2 rows and 3 columns. Hence the order of the matrix 2 by 3. Each and every entries are 0. That's why it is known as null matrix, void matrix, or 0 matrix. Yes. Next is square matrix. A square matrix is a matrix in which number of rows equal to number of columns. Number of rows and number of columns, if they are equal, we call the matrix as a square matrix. If they are unequal, it is treated as a rectangular matrix. Yeah, 2 by 3. Yes, Ramappa. A matrix of order 2 by 3. 2 by 3. 2 rows, 3 columns. Hence, it is known as rectangular matrix. Square matrix alli number of rows and number of columns should be equal. Example 2 by 2, 3 by 3. Clear no Ramappa? In the case of column matrix, number of columns should be 1. In the case of row matrix, number of rows should be 1. In the case of rectangular matrix, number of rows ಮತ್ತು number of columns unequal ಆದ್ರೆ ಸಾಕು. ಎಷ್ಟು ಬೇಕಿದ್ರು ಇರಬಹುದು, ಬಟ್ ಎರಡು unequal ಆಗಿರಬೇಕು. ಅದೇ ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ number of rows and number of columns are equal. Clear no? Number of rows and number of columns are equal. Yes. So, if I consider example for square matrix of order 1, 10, order 1 by 1. One more example. B equal to 1, 2, 3, 4. C is equal to A, B, C, D, E, F, G, H, I. First one, if I consider number of rows equal to number of columns equal to 1, or else order of the matrix 1 by 1. In the second, order of the matrix 2 by 2. In the third, 3 rows and 3 columns, so order of the matrix is 3 by 3. Number of rows should be equal to number of columns. ಏನಾದ್ರೂ ಡೌಟ್ ಉಂಟಾ? ಕ್ಲಿಯರ್ ನೋ ರಾಮಪ್ಪ? ಯಾರಿಗಾದ್ರೆ ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. For square matrix, we can, yeah, yes, Yogita. 2 by, see here, 1 by 1 is a square matrix. Matrix consisting of 2 rows, 2 columns is also a square matrix. Matrix consisting of 3 rows and 3 columns is also a square matrix. No restriction. Number of rows and number of columns should be equal. ಅದು 1 ಆಗಿರ್ಬೋದು 2, 3, 4 ಯಾವುದೂ ಆಗಿರ್ಬೋದು. But the thing, number of rows should be equal to number of columns. Yes, Dilip, what's your doubt? You can ask. You can ask your doubt. Square matrices. Yes, Kumar. In the case of square matrix, number of rows is equal to number of columns. ಈಗ ನಾನು m rows ಮತ್ತು n ಕಾಲಮ್ ತಕೊಂಡ್ರೆ m should be equal to n. ಅದಕ್ಕೆ example, both m and n are equal, say 2 by 2 and 2. Order of the matrix 2 by 2. m ಮತ್ತು n unequal ಆದ್ರೆ that will be a rectangular matrix. m ಮತ್ತು n equal ಆದ್ರೆ square matrix. Yes. Clear ಅಲ್ಲ? Yes. ಅದರಲ್ಲಿ ನಾನು ಯಾವುದು ಆರ್ಡರ್ ತಗೊಳ್ಬಹುದು. ಆರ್ಡರ್ 1 by 1, ಆರ್ಡರ್ 2 by 2, ಆರ್ಡರ್ 3 by 3. All are examples for square matrix. ಅದೇ ನಾನು 3 by 2 ತಕೊಂಡ್ರೆ 3 rows 2 column, hence rectangular matrix. ಗೊತ್ತಾಯ್ತಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್? ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆದ್ರೆ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಶುಡ್ ಬಿ ಈಕ್ವಲ್ ಟು ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್. ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆದ್ರೆ ನಂಬರ್ ಆಫ್ ರೋಸ್ ಮತ್ತು ನಂಬರ್ ಆಫ್ ಕಾಲಮ್ಸ್ ಆರ್ ಅನ್ಈಕ್ವಲ್. ಸಾರಿ. ಓಕೆ, ಝೀರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಝೀರೋ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂದ್ರೆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ವಿತ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಎಂಟ್ರೀಸ್ ಆರ್ ಝೀರೋ. ಅದನ್ನ ನಾನು ಯಾವುದೂ ತಕೊಳ್ಬಹುದು. 2 by 3 is an example for rectangular matrix. 0, 0, 0 is an example for row matrix. 0, 0. Again a zero matrix as well as column matrix. 0, 0, 0, 0. Example for zero matrix as well as a square matrix. Clear, no? Any doubt? Yes. Next. Diagonal matrix. What is a diagonal matrix? A diagonal matrix is a square matrix. ಇನ್ನು ಎಲ್ಲ ನಾನು ಸ್ಕ್ವೇರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ನ ಸ್ಪೆಷಲ್ ಟೈಪ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದೆ. A square matrix in which I'll consider a square matrix A, B, C, D, E, F, G, H, I. Consider the entry A, E, I. A is 1/1 entry. E is 2/2 entry. I is third row, third column entry. These are called diagonal entries of the matrix, or else simply principal diagonal. A, E, I are called principal diagonal element. A11, A22, A33. If I consider 2 by 2 matrix, A11 and A22 elements from left to top to right to bottom. Elements from left to top to right to bottom are called diagonal elements. Now, let me consider diagonal matrix. Diagonal matrix is a square matrix in which non-diagonal entries are 0. So I'll consider the diagonal entries first. 2, 1, -4. These are the diagonal entries. Non-diagonal entries are 0. Yes. Here no? A diagonal matrix is a square matrix in which diagonal entries are non-zero real numbers. Can be anything, but non-diagonal entries are 0. Yes. A diagonal matrix is a square matrix in which non-diagonal entries are 0. Yes.